The question says that the clinic has several doctors, so it has several doctors, right? And thousands of patients are attended at this clinic. So many patients come to the clinic each day. At one time, there is only one doctor in the clinic. Meaning there, although there are several doctors who work for the clinic, but at one time there is only one doctor in the clinic. Remember, in database questions you have to you have to pay very close attention to the details that have been mentioned. Okay, so we have several doctors, but at one time there's only one doctor in the clinic. Okay, the clinic stores patient, doctor and appointment data in a relational database. Okay, so underline the primary key for each table. In the patient table, we can clearly see that the patient ID is going to be unique, so this is our primary key. In the doctor table, clearly the doctor ID is going to be the primary key, and in the appointment table, well, we'll have to actually, because the appointment date cannot be unique, the appointment time cannot be unique, and the doctor ID cannot be unique, and the patient ID cannot be unique. Let me show you why we have to be careful when we are selecting, the ID for the appointment table. What I've done is I have quickly created a table and entered some fictitious values so that we can understand. Okay, appointment date itself cannot be the primary key, as we can see that this date keeps getting repeated many times, right? Appointment time itself cannot be the primary key, because we can see there's 8 o'clock here and 8 o'clock on another date. Alright, so 8 o'clock appears twice, for example. Doctor ID we can see is getting repeated many times, right? And patient ID we see also is getting repeated many times, meaning the patient has visited the clinic more than once, right, on different appointments. So we can clearly see that no single field qualifies as the primary key, so we can select a compound primary key. And the compound primary key, if you do careful analysis, is going to be the appointment date and the appointment time, okay, collectively, because this is always unique. On 1st of January 2018, 8 o'clock, this is unique, right? This appointment is unique. There can be no other appointment at that time. Okay, 1st of January 2018, 8:15 is also going to be unique, because there can be no other appointment at that time, right? Every other combination, if you carefully take a look, can appear twice. For example, doctor ID 1 and patient ID 1. You can see that this doctor whose ID was 1 checked the patient whose ID was 1 on this date, right? On the 1st of January, and you can also see that the same patient visited the same doctor on the 2nd of January also. So you have to do some careful analysis. With careful analysis, we've reached the conclusion that appointment date and appointment time is going to be unique. So this is going to be our compound primary key. Therefore, this is going to be our compound primary key. Then this question says complete the following entity relationship diagram for this design. And in this design we have 3 tables, right? We have the patient, doctor and the appointment table. So we're going to fill these up: patient, doctor and the appointment table. Okay, what is going to be the relationship between these tables? Looking this way, from the patient to the doctor, one patient can be treated by many doctors. Okay, looking this way, from the doctor to the patient, one doctor can treat many patients. Okay, looking from the patient side towards appointments, one patient, looking this way, right, one patient can have several appointments, right? Okay, and now looking this way, one appointment can have one patient only. Okay, so one appointment is made for one patient only. Okay, so this is going to be looking this way, there's only going to be one patient for one appointment. Okay, looking from the doctor side towards the appointment side, one doctor can have several appointments, right? Can be attending many patients in different appointments, right? And looking from the appointment side to the doctor, during one appointment there's only going to be one doctor, right? So one appointment is only going to be for one doctor. It's not like one appointment can have multiple doctors attending the patient, because remember, earlier on in the question he said at one time only one doctor is going to be available in the clinic, which means what? So when you make an appointment, you're only going to be checked by one doctor. So looking this way, one appointment is going to be for one doctor. Okay, although the question is not asking for it, let me explain a key concept here. If you have a many to many relationship between two entities, like between the patient and the doctor we have a many to many relationship. If you have a situation like this, we always need to create a third table. Let me explain that. If you ever have a situation where two tables have a many to many relationship, then we need to create a third table. Okay, so we are going to create a third table in a situation where we have a many to many relationship, and that third table, let's call it the patient doctor table. So we are going to take both the names and join them together. Now, this is not really necessary, but it's a good way, right? So we're taking this patient name and the doctor name and we're creating a third table. This is not necessary, you can give it any name, but okay. So we've created a third table, and this is linked to this table and this is linked to this table. Remember, this middle link that was here is gone now. Okay, so what we've done is we've created a third table, and this relationship moves to this point and this relationship moves to this point. It is always like that. It is always like that. Okay, so it's always going to be one patient to many patient doctor and one doctor to many patient doctors. So that's how the relationship is going to be broken. Remember, that is always the case. We always create a third table, and this table is called the link table. And this table, the patient doctor table, if I was to define this, is going to have two fields only. It is going to have the patient ID, which is the primary key of the patient, and the doctor ID, which is the primary key of the doctor. Remember, this is going to be a compound primary key, and this is always the case with linked tables. Let me quickly show you another scenario so that this concept becomes clear. Let's assume we have a situation like this. A student is taught by many teachers, and a teacher teaches many students. In this case also, once again, we are going to create a link table, right? And the many part is going to come here, and we're going to create a link here also, and the many part is going to come here. So this table is going to be called our link table, right? And once again, the student teacher table will have two fields only, right? It will have two fields only, the student ID and the teacher ID, and we are going to have a compound primary key in this case. So this is always the standard. Anytime you see a many to many relationship, this is your answer. Okay, next he says, describe why this update could cause problems with the existing data stored. So with the existing data that is stored, remember, you are updating the doctor's table, right? So the doctor ID is part of the doctor's table. But if we carefully take a look, the appointment table also has the doctor ID. This also has the doctor ID. The doctor ID was here and you updated it in the doctor table, but the same doctor ID, which was what? Which was 117, right? That ID was also, it could also have been part of the appointment table. So when you change the doctor ID in the doctor table, you updated the doctor ID from 117. Instead of 117, you changed it to 017. But what about all the entries that were here in this table, in the appointments table? What is going to happen to those entries, right? You updated the value of Dr. ID 2017 in this table, but what about, uh, what about the Dr. ID 117 that was part of the appointment table? Basically what I'm saying is, what if that Dr. ID 117 was had several records in the appointment table also? You could find this Dr. ID there in the appointment table also. What would happen now is something called referential integrity, because basically we'll have some entries with Dr. ID 117 in the appointment table. These were already there, but later on we changed the Dr. ID to 017. So now we don't have a Dr. ID 117 that is inside the doctor table, yet we can find that Dr. ID 117 in the appointment table. This is called referential integrity. So the referential integrity is being violated. So what we can say here is that we'll find data inconsistency, right? Data is not going to be consistent, right? Data inconsistency in the tables doctor and appointment. So we'll have data inconsistency, and secondly we can say that a referential integrity is violated. Basically Dr. ID 117 could be found in the doctor's table. Well, Dr. ID 117 cannot be found in the doctor's table because it has been modified to 017, but this Dr. ID 117 is still there in the appointments table, right? It was not updated there, so there is going to be an issue here, and that is going to be called violation of referential integrity. Okay, next he says, write an SQL script to display the date and time of all the appointments made by the patient with the patient ID of 556. And remember, this is our appointment table, right? So what we want to do is we want to select the date and time of the appointment, which means what? These are our fields and we want to copy the exact names, right? So we want to say select appointment date, make sure you copy the field names properly, and the appointment time. This is what we want to be shown, right? This is going to be shown, this is going to be displayed, right? And which table are these fields from? From the table appointment, and which record do we want to select? We want to select the record where the patient ID is, equals 556. So that's our answer, right? That's our answer. Okay, what if we wanted, let me, even though this has not been asked in the question, but what if we wanted to show all the appointment dates and appointment time in the in this table, right? What if we wanted to show all the appointments? So then we would have said something like select appointment date, comma, appointment time. So the appointment date and the appointment time would have been shown from the table appointment. That's it. We don't need to search for any specific record. So we are not going to mention where. So we are not going to mention a selection criteria here as such. We're just going to say select appointment date and appointment time from the table appointment, and because we've not mentioned a where condition here, it's going to select the appointment date and appointment time from all the records. So appointment date and appointment time, if you have 10 records, if you have 10 records in the table, appointment date and appointment time for all the 10 records are going to be output in this case.